Okay, the last section in chapter 6 that we're going to talk about is probability and predictions. And this is chapter 6.9. Alright, this is the words to know that you need to know for this section. And you are going to have to do some work on this one. So go ahead and copy these down and look these words up in your book and get these definitions all in your notes. And you can replay me when you get it all done. Alright, and then here is the key concept for the day, and this is probability. And so go ahead and get all of this down, including this down here, and pause me and replay me when you are finished. Alright, so the probability of an event is a ratio that compares the number of favorable outcomes to the number of possible outcomes. Okay, number of favorable outcomes to the number of possible outcomes. All right, and then of course we've got that ratio word in there. Okay, and that's just, going back to saying ratio is a comparison of two things, and here we're going to compare favorable outcomes to the number of possible outcomes. And down here, we say that the probability of an event is always between 0 and 1 inclusive. And inclusive just means including in between anything between 0 and 1. Okay, so the closer the probability is to 1, the more likely it is to occur. And, well, the more, vice versa, the more close it is to 0, well, the less likely it is to occur. So at 100%, it is absolutely certain to occur. Impossible to occur is at 0. And then right smack dab here in the middle, we've got equally likely to occur at 50%, 1/2, or 0.5. Okay, so here we go. Suppose a dice is rolled. What is the probability of rolling a prime number? Okay, so first of all, we've got to talk about what a prime number is. Well, we've got the numbers on a dice, which is 1, 2, 3, 4, 5, 6. Okay, six-sided dice. You just roll it on the ground. You play it in Monopoly or whatever you're doing. And so these are the numbers on the die. And so we got to talk about what the prime numbers are. Well, a prime number is a number that is only divisible by 1 and itself. And this does not include 1. Okay, so which ones of these is only divisible by 1 and itself? Well, 2, 3, and 5. 4 is not, because 4 can be divided by 2. 6 is not, because it can be divided by 2 and 3. Okay, so we are going to write the probability that the number is prime, and you write it as probability, big P, and then whatever you're kind of looking for, prime, which is what the question is asking, equals the number of favorable outcomes over the number of possible outcomes. All right, and we're going to look at our little bit of data right here. How many of these are going to be our favorable outcome? Okay, well, I could either roll a 2, a 3, or a 5. So that's 3. 3 favorable outcomes out of the number of possible outcomes. Well, there's 1, 2, 3, 4, 5, 6. So this is 3, 6. So the probability of rolling a prime number with a dice is 3, 6, or you always want to reduce 1/2. Okay, so this next example, suppose 2 dice are rolled. Find the probability of rolling an even sum. Okay, so what I want you to do is I want you to make a sample space of rolling when you roll 2 number cubes or dice. And what you do is a sample space, as you saw earlier when you did your definitions, is the set of all possible outcomes. Okay? Now here is what a sample space looks like. So I want you to get this in, and I want you to copy this all down. I know it's a lot, but this is your sample space. Okay. Now the question asks, find the probability of rolling an even sum. Okay. So we're going to go through here, and you got to find your sums. All right. So the first one is 2. 2 plus 1 is 3. 3 plus 1 is 4. 5, 6, 7. I'm going to pause this so I don't waste too much time, but you guys go ahead and finish up. Okay, so my little recorder thing was right in the way here, and I couldn't finish up, but here we go. And as you were doing it, did you see some sort of pattern as we go 2, 3, 4, 5, 6, 7? We also go 2, 3, 4, 5, 6, 7, and so on. Okay, so now we're going to see the probability of rolling a even sum. Okay, so in order to find the probability, we need to find the number of favorable outcomes over the number of possible outcomes. Okay, so the number of favorable outcomes is how many of these have a even sum. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have a total of 18 favorable outcomes over a total of possible outcomes, which in this case is, well, we've got 1, 2, 3, 4, 5, 6, and we have 1, 2, 3, 4, 5, 6, 6 rows of 6, which makes 36. Okay, but we want to write that, of course, in lowest terms. So this is actually 1/2. So the probability of rolling an even sum with 2 dice is 1/2. All right, so now we've got a table showing the results of an experiment in which a coin was tossed. Find the environmental probability of tossing a coin and getting tails for this experiment. Well, the experimental probability is what actually occurs when conducting a probability experiment. Okay, so we want to know the number of times tails occurs over the number of possible outcomes. Okay, so let's see. Let's look at what we're given. We've got heads, we've got tails, and they've given you a little frequency chart so you don't have to tally up all those little tallies they gave you. So somebody, Joe Schmo, he flipped a coin, and he hit heads 14 times. And he hit tails 11 times. Well, the question asks you to find the experimental probability, which is what actually happened, of tossing a coin and getting tails for this experiment. So the number of times getting tails is 11, and the total is over 25. And I got that because I added both the tails with the heads versus tails, excuse me, and I just got that total as being 25. Okay, and for your practice problems, I'd actually like you to go into the book. They are pretty long to type, so I'm just going to have you do it out of the book. This is page 313. I'd like you to do number 12, 16, 22, 26, and 32, and I would like you to have those for class tomorrow. And if you have any questions, please write them on your papers so you remember them to ask me them tomorrow. Good luck.